we have our quadratic in the form of ax squared plus bx plus c equals 0. So we have our a, b, and c values. All right, very easy to identify those if we need to, because you see below the formula that we're going to be working with, this lovely looking formula, relies on being able to identify what the a, b, and c values are. All right, so being able to pull it out of the quadratic when it's in its general form is really important. All right, but we want to know where that formula came from. All right, and there are multiple derivations of this formula, but the most popular one, at least in my opinion, is the completing the square method. All right, so I'm going to rewrite. So essentially, this is the problem. Before it would be something like 2x squared plus 5x plus whatever. Now it's ax squared plus bx plus c equals 0. All right, so no numbers, only variables. But we're still going to follow the same process. All right, the first two steps are interchangeable. We need to have a leading coefficient of 1, and we also need to get rid of the c value, or whatever the constant term is. So you can do that in whatever order you want. All right, so I'm going to move the c value over first. All right, the way I'm going to do that is by subtracting c from both sides of the equation. All right, subtraction property of equality. It works even with letters. All right, so ax squared plus bx, leave a little space to complete the square, is equal to negative c. All right, 0 minus c, negative c. All right, now I'm going to divide every term by the a value. All right, whatever the a value is, we divide by that. If it were a 2, we divide by 2. Here it's just a. So I'm going to divide every term by a. All right, it only cancels away in one place though. All right, so we're stuck with fractions everywhere else. All right, a divided by a gives you a 1, because anything divided by itself gives you a 1. So that part is nice. So, but unfortunately, that's the only part that's nice. X squared plus b over a x, leave a little space to complete the square, is equal to negative c over a. I want to write that b over a as a coefficient of x, all right, because we need to do our side work in a sec. And I want to be able to easily identify the quote-unquote b value, all right, because the b value isn't just the letter b anymore. It's the coefficient of the variable x, all right? So this expression here, just following the same approach that we've been using this whole time, yeah, I know it's a little bit more intimidating because it's got variables all over the place and constants and coefficients and things like that, non-numerical, but it's still the same process. So with our side work, I take whatever the b value is, so side work, whatever that b value is, I cut it in half and square the result. All right, so that b value, quote unquote b value, is b over a. All right, so we get a little bit more work to do here. It's not just a simple matter of saying, all right, what's 4 cut in half? 2 squared 4. Yeah, plug it in. You know, we have to manipulate this a little bit. All right, so I have to take b over a and divide it by 2. If I take a fraction and multiply it by just a whole number, that whole number could be written as a fraction. That fraction would be that whole number over 1. So I'm going to rewrite this so that that 2 is over a 1. So then I can do a little keep, change, flip. So I'm going to take this expression out and do a little keep, change, flip. B over a times, instead of 2 over 1, 1 over 2. All right, and that's going to give me b over 2a. That expression is the simplified form of whatever is in the parentheses here. So now I have b over 2a as a quantity squared. All right. Now I have to square the top and square the bottom. If I take the top and square it, that's just b squared. All right. So b squared. The bottom, I'm going to take each piece and square it. I have a 2 squared, which is going to become a 4. The a squared, which is just a squared. All right. So b squared over 4a squared. All right. So that's the number that gets plugged into the gap. All right. So we plug that into the gap. We add it to the other side also. So plus b squared over 4a squared plus b squared over 4a squared. Next step in completing the square is to factor the left-hand side. Doesn't seem like it would be possible at this point, but it's very possible. We just did all the side work that allows that to happen. And simplify the right-hand side. All right? Not a simple matter of just throwing it in your calculator and getting an answer. We'll have to do this one by hand. All right? So I'll do some side work with that in a sec. But the left-hand side should be easy, right? Because it's a perfect square trinomial. This side work leads us to a perfect square trinomial. Right? That's the whole point of the side work. So if you know that it's a perfect square trinomial, then you know that all you need to do is take the square root of the first term, put that here, take the square root of the last term, put that here, and carry down the sign of the middle term. All right, and write it as a binomial squared. Square root of x squared is x. The square root of b squared over 4a squared, that should be pretty easy, because if you go back to this step here, we took b over 2a and squared it to get that result of b squared over 4a squared, which means that the square root of b squared over 4a squared has to be whatever that expression was before it was squared, which would be b over 2a. But you don't like that, you can, I don't want to sound condescending, but you could reinvent the wheel basically. And that is to say, take the square root of the top and take the square root of the bottom and make a fraction out of that. The issue with that is that, well, it's not really an issue. It's more of a hope. The hope is before too long you'd realize that, wait a minute, that's the same thing as this expression over here. You do that enough times, you start realizing, I am reinventing the wheel. I'm doing unnecessary work. And that's come up repeatedly in the numerical completing the square problems, where people would get that C value, it'll be something like 49 over 16, and they'll say, what's the square root of that? And I'd say, well, what was the thing that you squared to get that number to begin with? That would make it the square root. If I told you or asked you, what is 4 squared? Hopefully you would say 16. If I then turn it around immediately after that and said, what's the square root of 16? Hopefully without any hesitation, you would say 4. I'd like you to also say negative 4. But you should realize that the thing you just squared to get that 16 is going to be the square root of the 16. All right? It's an invertible relationship. You go one way to get the power of 2. You go the other way to get the square root. All right? Now, on the right-hand side, we need some more side work. All right? I have to add 2 fractions. You know what? I'll just do it even more on the side. So I have negative c over a plus b squared over 4a. If you're going to add 2 fractions, you need a common denominator. All right? Oh, sorry, b squared over 4a squared. All right? So I'd have to think about what I would need to multiply my first fraction by in order to make the denominator of my first fraction the same as the denominator of my second fraction. All right? So I look at the ingredients that make up a 4a squared. 4a squared is the same as 4 times a times a. All right? So looking at my other fraction, I see that I only have a single a. So I need another 4 and I need another a. All right, so I'm going to multiply this fraction, top and bottom, by 4a. All right, that's going to make a 4a squared on the bottom, and on the top, it really doesn't matter what it makes. I have to multiply the top by the same number in order to keep the equation equivalent. Oh, I'm sorry, the fraction equivalent to what it was previously. All right. If I don't multiply the top also by 4a, then it's a different fraction. All right, different value. But I can multiply now. I'll have a 4a times a negative c. 4a times negative c is negative 4ac. We tend to write that in alphabetical order. Over 4a squared. That's what this boils down to. Plus b squared over 4a squared. Now I can put these two fractions together. I could write it as negative 4ac plus b squared. But if ultimately what I'm trying to get is that lovely looking formula you see lower in the page, you'll see that part of that formula is b squared minus 4ac. So I'm going to write it like that. Right? So we could write it as negative 4ac plus b squared over 4a squared. But by the commutative property, I can change or swap these two terms and make it b squared minus 4ac. It's just a general rule of thumb that you typically want to have any negative values go after positive values. All right. Products get written in alphabetical order. So if you have letters, a ton of letters in your expression, and they're all being multiplied, you just work down the alphabet, and then anything that's positive would come before anything that's negative. All right, just to write it as a subtraction instead of an addition involving a negative. All right, so the whole right-hand side, this whole shebang here, corresponds to this. All right, so this led to this, and this is going to replace that original expression. All right, so I have x plus b over 2 squared, b over 2a squared is equal now, instead of this expression here, it's equal to b squared minus 4ac all over 4a squared. So we've successfully completed the square. It just doesn't look very pretty. But the idea was to write the expression, the trinomial, as a binomial squared, and we did that. All right. Now we have to go the distance and solve for x. So I'm going to rewrite just to kind of give us something clean to work with. We have a binomial squared on the left-hand side. The whole point behind completing the square is to get rid of that square, that power of 2. We do that by taking the square root. You take the square root of the left side to get rid of the power of 2. You take the square root of the right side because you took the square root of the left side. All right, it's all about fairness, equality. I mean, equal sign, equality. You got two kids in a room, you give one a lollipop because they asked for it, and then the other kid says, hey, what about me? Like that commercial. The only one that I can think of that involves a lollipop. So I think it's a car commercial. It's about fairness, like about getting a good deal. It might be an AT&T commercial. Whatever. But the idea is you do it on one side because you need to do it on the one side. You do it on the other side because you did it on that first side, right, to keep it equitable. All right, but once you do that, power of 2 goes away. X plus b over 2a, because the radical and the power of 2 cancel. On the right-hand side, you have a big old radical, but the bottom of that big old radical is a perfect square. You see it's got a 4 in it. We know that's perfect. The a squared is perfect because it has a power of 2. Right? Any even power is considered a perfect square. All right, so I can split up this radical and make it plus or minus b squared minus 4ac. All right, we chose to take the square root, so I got to put the plus or minus in there. But then I can put it, instead of over a radical 4a squared, I could put it over a 2a. All right, because again, this is the same as looking at it as radical b squared minus 4ac over radical 4a squared. All right, but you don't have to show this intermediate step if you don't want. I just figure I put it on paper for you. All right. So then my only objective at this point, and actually it's been my objective for a couple of steps, has been to get x alone. All right. So that is subtract the b over 2a from both sides. It'll cancel on the left. You'll get x is equal to, we always write the plus or minus bit at the end, so negative b over 2a plus or minus all this stuff. The square root of b squared minus 4ac all over 2a. Now that would actually be an okay way of writing your final answer here, but the general way of representing the quadratic formula has it all in one fraction. Now fortunately it's already got a common denominator, so that's not bad. All right, just putting the tops together over a 2a. So x is equal to, put our tops together, negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and so this is the quadratic formula. Now you're not going to have to invent this formula every time you want to use it. That kind of defeats the purpose of inventing it the first time. I mean, look at all this. This is supposed to be a shortcut. Like, how is this a shortcut? Well, if you start off with the thing we finished up with, the x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, you start off with that and plug in the coefficients a, b, and c appropriately, it'll get you to the final answer very, very quickly. All right? I am going to ask you to do this process once, though, on an exit ticket, I'll say 2 weeks from now. All right? I don't want to rush it. I'll give you some time to study it. All right? But yeah, it's not something you're going to have to do from beginning to end. It is part of the Regents curriculum, so you need to know it. Yet, I've never seen them ask it on the Regents, but because it's in the curriculum, I guess technically they can ask it. They also give you the formula on the Regents exam, and I'll show you how to use it in a minute. I can tell you that I will not be giving you the formula for any assessments. I expect you to know it. All right? It's not a difficult formula to memorize, and it's so important moving forward that if you're always looking up this formula, you'll be at a disadvantage in future years. So the regents will give it to you. You'll have a little formula sheet, but any assessment I give you, I'm not giving you the formula, right? You'll need to know it, right? It's not very often that I ask you to memorize things, just straight memorize formulas and things like that. This is one of those instances, right? So applying the quadratic formula. Well, one thing that's really important about it is, and you can see the blurb there, but I'll direct your attention to the last 4 words. Method that always works. At the heart of that is the always part. We like always. Something that will always work, that's great. Completing the square always works. But as we've learned over the last couple of weeks, completing the square takes a little while. All right? The quadratic formula is a numerical approach to completing the square. Right? It's not algebraic, it's numerical. All right? So if a question asks you to solve algebraically, you can't use the quadratic formula. All right? That's not an algebraic approach, it's a numerical approach. But if a question asks you to just solve, like you see below here, then you could use whatever method you want, even if it is algebraic. You might look at this and say, yeah, I know it's supposed to be simple, I just don't like it. Then when you have a choice, you don't have to use this method, but there will be circumstances where it says using the quadratic formula, find the solution. All right? So what we do is we pull out the a, b, and c values from the quadratic. If it's in the general form ax squared plus bx plus c equals 0, general form of a quadratic, that's what we want. We don't have to move things around like completing the square. We don't have to create a space by moving the c value. It's just make sure it's equal to 0 and everything's in descending order. Then whatever the coefficient of the x term is your a value. Whatever the coefficient of your x squared term is your a value. Whatever the coefficient of your x term is your b value. And whatever the loose coefficient or constant is your c value. All right? So that tells me that a is equal to 2, b is equal to 5, c is equal to -3. This stuff gets plugged into the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right. So this is all one fraction, because I've seen this before. I've seen people writing the quadratic formula like it's like this. That's not equivalent. The negative b is part of the numerator. All right, so keep that in mind, despite my sloppy handwriting. So what I'm going to do is I'm going to replace every a value with a 2. I'm going to replace every b value with a 5. Oops, highlighted the wrong thing. And the c value with a -3. So x is going to be equal to -5 plus or minus the square root of b squared, so 5 squared, minus 4 times 2 times -3 all over 2 times 2. You'll notice that I'm putting parentheses for like everything, like all over the place. Anytime you make a substitution in the quadratic formula, it's in your best interest to put it in parentheses, right? Because you could run into, especially if you're using a calculator to evaluate it, you could run into issues with signs, right? Especially when you're raising to a power of 2. If you put into a graphing calculator or even Desmos, I'll just show you real quick when it opens. If you put in a negative and square it, it tells you that the result is negative unless you put that negative in parentheses. Now, it didn't come up in this problem, but it will. And so I just want you to be prepared. Come on, any day now. Let's do it. You can do it. There we go. So let's say, for example, I had -2 and I wanted to square it. I type in -2 and I square it. It tells me that's -4. That's not correct. -2 squared is +4. So I'd write it as parentheses -2, close them up and square it. That'll give me the +4. All right. If you use parentheses in your quadratic formula, then you could type the expression in just as you see it, and it'll give you the solution correctly. You wouldn't have to show any intermediate steps. All right, so I'm looking at x is equal to, well, -5 is easy enough. I don't need a calculator for that. We have to assume that we could have an irrational answer here. So I'm just going to compute whatever is under the radical. I'm going to exclude the radical. All right? Because if I put a radical in my calculator and all this stuff underneath it and I get some hideous decimal, I can't put down the hideous decimal. I have to put down something that's in irrational form, like a simplified radical. So I'm going to work whatever is under the radical rather than the radical itself. So I'm going to type in 5 squared. Now, if you could do this in your head, even better, but I'll just say what I've been saying all along. Try doing it in your head, and then because you'll be taking a quiz or a test and you're nervous and you don't want to make a mistake, check it by putting it in the calculator. All right, so you put all that stuff in there, you get a 49. Luckily, it's a perfect square. Over 4, 2 times 2 is 4. So in this case, you could have put the radical in the calculator and it would have worked out, but don't want to take that chance. It's very rarely going to work out that way. So square root of 49 is 7. Now I have something that's rational that I could work with. I can split it up. -5 minus 7 over 4. -5 plus 7 over 4. Very similar to completing the square at this point. -5 minus 7 is -12. Divided by 4 is -3. -5 plus 7 is 2. Divided by 4, 2/4, 1/2. So x is going to be equal to -3 or 1/2. All right. So if you get rational answers, and you don't always get rational, we've seen plenty of instances where the answer involves a radical. If you get rational answers, it means that the original quadratic was factorable. All right. Doesn't mean that it's easy to factor. It just means that you could have factored it. All right. So, I mean, it's kind of a little late in the party to recognize that. Ideally, if something is factorable and you have a choice, you'd like to recognize it immediately. But what I tend to do once we start putting all these concepts together, because we're learning three plus the calculator method, so 4, maybe 5 methods for solving quadratics. Once we put it all together and start working with them all interchangeably, I'm going to recommend that you at least attempt to factor first. Because if it's easily factored, then you could save yourself a lot of work. All right, but the next one, you see you have an x squared. That's an assumed 1x squared. So we know it's ax squared plus bx plus c is equal to 0. A value is 1. B value +3. C value -5. All right, so we list those values out. You don't actually have to list out A equals this, B equals that, C equals that. I just appreciate it when you do, because if you make a mistake in the quadratic formula and you've listed your A, B, and C values out, if you accidentally have, let's say, a -3 for B, I can look at it and say, oh, that's where you went wrong. All right, it's an easy way of identifying the mistake. And if it's just a simple matter of, oh, you tacked a negative onto the B instead of a positive, then it's a half-point deduction. It's not a big deal. But if I have to go into the quadratic formula, like if you don't give me this, and I have to sift through this, I might not be able to figure out where you went wrong, and it might cost you more points. So it's really in everybody's benefit. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so again, we replace the a value with a 1. There's two of them, so a values. The b values with a 3, and the lone c value with a negative 5. We make our substitution. So negative 3 plus or minus, so parentheses, all right, so we're going to have a 3 in here, a 1, a negative 5, and a 1. I'll use my highlighter again. We're going to simplify the thing under the radical. You simplify that. If you want to try it in your head, that's great. If not, you put it in your calculator again, just parentheses 3, close it up, square it, minus 4, parentheses 1, close it up, parentheses negative 5, close it up. All right, so I got a 29 here. All right, so in my next step, 29 is going under the radical. So I'm going to have x is equal to negative 3 plus or minus the square root of 29 over 2. Now that 29 is not a perfect square. It's actually a prime number. It's not something that could be broken down. So we're done. That's the beauty of the quadratic formula. When you have a certain type of irrational answer, it's very easy. The problem is you don't always get that. Sometimes it's a little bit more complicated. All right, but you have two cases here that we're looking at, or have looked at. One where you have a rational answer, one where you have an irrational answer. You could also have instances where you have a radical that needs to be simplified. All right, so let me grab one of those two. I just got to remember which one is one of those. Let's see. Well, you know, either way, I should do one with a fraction in it anyway, so I'll do number 3. So the a value, the b value, and the c value. Understood negative 1. So we have a value again. B value this time is negative. C value also negative. 1/2. Negative 1. Negative 4. So again, the formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. A values, my b values, and my c value. So negative 1. So a little double negative action going on there. Negative 1 squared minus 4 times 1/2 times negative 4. Never make my radical big enough. All over 2 times 1/2. All right, a little more highlighters. Computationally, it's not that bad, even though there are fractions. The double negatives make a positive. Plus or minus. Oh, I don't need a radical that big. On the bottom, I'll do the radical in a second, but on the bottom, 2 times a half, it's just a 1. Which would disappear anyway, because anything over a 1 is itself. So it's really just a matter of whatever's under the radical, which again, you could probably figure out by hand or computationally. But you don't want to make a mistake, so you type it in. Minus 4 times, I'm going to put, instead of a 1/2, I'm going to put a 0.5, just so I don't have to get the fraction tool involved. And now I get a 9. Of course it's rational. I wanted it irrational, but it is what it is. So it's still another type of problem, which is good. 1 plus or minus 9 over 1 is really the same as 1 plus or minus 3, because square root of 9 is 3. So x is going to be equal to 1 minus 3. So again, this breaks up. 1 minus 3, 1 plus 3. So x is going to be equal to a negative 2 or a 4. All right, so I am shockingly going to ask you to do just a single problem for homework to be submitted. I'm going to call it an exit ticket. You'll notice in this case the 2 is on the wrong side. What do you think our first step is there?
Move it to the right side.
Move it to the, move to the correct side, the other side. Right? So I'll put a submission area up on Schoology, but this will be your exit ticket. Now, I want you to not skip this step. Write the formula in your submission, all right? So basically do it the exact same way I've been doing it in class, all right? And I just want to see that you have it, all right? And then tomorrow's going to be a practice day with this, because there's so many different variations with this that it can be a little tricky, especially when you get the radicals involved. But yeah, so just the one problem.